right, welcome to For Your Ears Only, a private podcast exclusively for WIS and company clients. I'm John Palumbo from Big Heads Network, and I'm here with WIS partner Paul Peterson. Hey, Paul.
Hey, John. How are you?
I'm great. So if you're a regular listener to this podcast, you know that we use it in a lot of different ways. I mean, we use it to introduce you to experts who could help you build crucial skills, especially all those soft skills that you always hear about. We use it to address current hot buttons and topics. We even bring you folks on, the WIS clients, to just hear your insights and expertise around relevant areas. But another thing that this format is really great for is giving all of us a glimpse into things that are emerging out there. So movements and approaches and even technologies. And that's what we'll be doing for this episode, focusing on a topic many of us have definitely heard about, but might not be completely clear on, and that's AI, or artificial intelligence. I mean, this is going to be a good one, Paul.
Yeah, definitely. I'm excited for this one. And I have to say, John's 1,000% right. These podcasts are a fantastic way to give us a glimpse into emerging movements, approaches, and technologies. And as I've mentioned in past episodes, we do a private podcast internally here at WIS for our employees, and we do some episodes for that purpose. And they're incredibly informative and eye-opening. So I'm excited to do that for all of you here today. And I think AI is a perfect topic for it, because it's a hot topic that definitely keeps getting hotter. And while we all know enough to be dangerous, there's a lot we don't know. And if you're anything like me, you probably have more questions than you do answers about it.
Yeah, well put. So this is essentially going to be an AI 101, for lack of a better way to put it. And we lucked out because our guest is a true AI guru, and that's Rob May. Hey, Rob, thanks for coming on.
Hey, guys. Thanks for having me.
Now, in the way of a little bit of background, Rob is a general partner at the venture firm PJC, where he focuses on the areas of AI, hardware, B2B, and SaaS. Prior to PJC, he was the founder and CEO of Tala, an AI and automation platform that transformed the way businesses deliver customer support. He was also the co-founder and CEO of Backupify, the world's first cloud-to-cloud backup provider, which was acquired for over $100 million.
Nice.
And as an angel investor, he's made over 70 early-stage AI investments. I mean, Rob also writes the world's most popular newsletter on AI called Inside AI. So I think it's safe to say we're in pretty good hands for this one. So let's get to it. So Rob, like we mentioned, a lot of us know a bit about AI, like Paul said, just enough to be dangerous, but I think we'd admit that there's a ton we don't know or understand. So what we want to do for this episode is just give everyone that sort of 101 introduction course, since we obviously can't get into all the details. In other words, we'll keep it high level, and maybe we could even kind of have you come back on at some point if there's an area we want to dig into. So that being said, I think a good place to start would be to have you tell us maybe what AI is, and maybe give us just a quick AI history lesson, since some would say that this idea has been around for decades, but maybe hasn't really become popular as it is now because of bandwidth and technology and all those things that just weren't available.
Sure. So when we talk about AI or machine learning, which we'll use interchangeably today in the podcast, what we really mean is we mean software that you can put out in the world and it will actually change from the way it's originally written. So to give you an example, most of the software that you write will do what it is told to do. So if you enter your password and username in a box, you'll log into the system. If if you're writing software for a car, when the car comes up to a red light, it will stop. What happens with AI systems is you're not deploying a series of rules. You're deploying a model, and that model is probabilistic. And that model can interact with the world and get retrained. So, for example, take a use case like identifying items in a mortgage document. Right, this is a common use case for AI now. All the states and all the companies have a lot of different types of documents, and it's a lot of work for a person to go through it and pull out all the right fields. So you can train an AI model to identify, for example, which field contains the W-2 income of the borrower. And that model might be 97 or 98% accurate. As it sees more types of documents, it can get more and more accurate. But what will happen is it'll identify that, and then it will need to be corrected on those occasions that it's wrong so it can get smarter. But the probability aspect and the fact that it can change is what's interesting, because when you extrapolate that across more complex problem sets, which will come over the next couple of decades, you start to think like, wow, how do we keep a handle on these things, and how do we know what they're going to do if they're out learning in the world? Now, when you look at the history of AI, it's filled with what we call AI winters. And AI winters are times that we thought AI was going to take off because there was some new technical breakthrough, and AI did not for various reasons. Now, the first one of these goes all the way back to the 1950s at MIT with a guy named Marvin Minsky. And I'm going to talk about machine vision in particular, because machine vision is what really led to this current explosion in AI. Marvin Minsky gave a grad student in the middle 1950s the task of, as a summer project, of solving machine vision, right? So teach a machine how to identify what's in an image. Over the next 60 plus years, we got about 70% accurate at that. And we did it by writing a lot of rules and trying to teach machines that, like, hey, if you see fuzzy ears, it might be a cat or some kind of animal. And, to go through this thing, and, the machines just weren't as good as we thought they would be. So in 2012, two things changed. First of all, we saw a resurgence in a type of neural net called the convolutional neural net. Now, there are many types of AI, and neural nets are only one type of AI. But neural nets never worked very well in the past because neural nets require a lot of data, and there had never been enough data. And they need labeled data. So they need data that somebody else has told, the machine what the image is. Mm-hmm. Well, that changed. Stanford came out with a data set called ImageNet that had over 1 million labeled images. And when you took this neural network architecture called AlexNet and you trained it on the ImageNet data, suddenly it beat the best performing models by like 15 percentage points, which was huge. And then between 2012 and 2015, it went from 70-something% accuracy to 95% accuracy on it classifying images in ImageNet, which is where humans are. And so you have this like 60-year time period, even more than that, where it took us to go from 0% accuracy to 70% accuracy. And then in 3 years, we went from 70% to 95%, right?
That's incredible.
Yeah.
Wow. So it might be a good idea just to, Rob, clarify maybe some of the more popular terms and buzzwords that are out there and that we all hear about and throw around, like machine learning and natural language processing and neural networks and all those things. Basically, maybe you could do like a little glossary or something for us.
Yeah, I'll give you a couple of terms that you'll hear frequently. But first, I'll clarify, when people talk about AI versus machine learning, there's really no good industry standard for what that taxonomy is. Some people would say that AI and machine learning are both different fields of data science. Some people would say AI is a subset of machine learning. Machines can learn other ways. Some people would say machine learning is a type of AI. So there's a lot of disagreement amongst the experts over the sort of formal hierarchy or taxonomy of the AI space.
Okay, so yeah, just tell us the ones that we just need. We don't give a shit about those. We only want to hear about the ones. Just tell us about the ones we need to know.
Yeah, so keep that in mind. But a couple terms that you hear a lot. You'll hear a lot the term NLP, natural language processing.
Yep.
And that really means taking language and trying to parse it out in a way that you can do something with it, right? And that could lead into NLU, which is natural language understanding. So that means being able to take the parsed language and actually perform a task. Or another piece of NLP might be NLG, which stands for natural language generation. So this might be a tool that can generate, summaries of reports or news articles, for example. So that's a lot of the natural language technology. You'll hear a lot about the term GPU. And GPU is a graphics processor that, sits in your computer and drives the screen. And it works very different than a CPU, which is your processor that runs all your programs. And the reason you hear a lot about GPUs is because The way a CPU works is you have a program and it runs through a series of steps. The way a GPU works is it's very simple. You have a million pixels in your screen, and every millisecond it recalculates for each pixel, a very simple computation in parallel. What should the color of the pixel be in the next millisecond, right? Somebody realized, some grad student in the mid 2000s realized the way that GPU works is the way a neural network works. So why don't I hack the GPU, which was designed to run your screen, to train my neural network? And now that's become a thing. That's why if you bought NVIDIA stock a couple years ago, that's why it's gone up so much, because people are using these GPUs to train and run neural networks now.
Interesting. So Rob, let's bring this to life a bit with some examples. Can you tell us about some of the companies out there, maybe even ones that you're invested in, that are doing a great job leveraging AI, and what are they doing with AI?
Yeah. Oh, I could give you so many examples, right?
Yeah.
But let me give you one that's sort of public and one that's private in terms of the status of the company. So I'm an investor in a company called Root AI. And what Root does is they build robots that pick fruit and vegetables for indoor farms. And so their first focus is tomatoes. And the reason this is important is because with a crop like tomatoes, if you can grow it indoors, you get 24 times the yield per acre that you get outdoors, because you can control everything about the environment indoors. And you get a better supply chain because, I live in Boston. You can put one of these right outside of Boston and grow it and ship it in, very quickly to the stores here and have fresh tomatoes, rather than having to grow these out in, Iowa or wherever else they grow tomatoes and ship them here. So Root one of the challenges that Root faces is, how do you know what to pick? So they have a robot that goes up and down, all inside the indoor farms every day, and uses machine vision to scan the tomatoes. And then they have a machine learning model that says this is a ripe tomato or this is not a ripe tomato.
So cool.
Or this is an almost ripe tomato, right? Then they have a machine learning model that tells their hand, like, how do you reach and grab this tomato and pull it off there? Because maybe you have to reach around a vine. Maybe it's bunched up with another tomato, all kinds of problems like that. So that's a really interesting use case for them, of lots of AI models to run the different pieces of this robot. If you look at a sort of public markets example, Google back in maybe 2014 or 2015 bought a company called DeepMind, and they paid like $400 million. DeepMind had no revenue. And everybody said, like, oh my gosh, this is so stupid. What are you going to do with this company? Well, one of the things Google did was they used DeepMind to build machine learning models about, Google has all these big data centers. So they built these machine learning models that sort of tried to predict power usage in the data center, when it might spike, when they could shut off other machines, etc. One of the things machine learning models are very good at, better than humans in many cases, is making predictions. So, Google spent a couple years developing this, training it on all the data from all their data centers. And I think they were able to save something like $1.5 billion a year in power costs, which more than made up for what they paid for DeepMind, right?
$100 million, exactly, 3 times on it. Yeah.
Yeah.
I love Root AI. That's awesome.
Really cool.
So Rob, look, I'm going to admit, and I'm that myself, and I'm sure this is true of a lot of the folks listening. We get our overviews about these emerging movements by reading like those quick hit, kind of easily digestible articles on Inc. or Fast Company or sites like that. But let's say you were writing an article for one of those outlets where you had to just summarize maybe the top 3 rules or tenets that company leaders need to consider or maybe follow in order to develop an impactful AI strategy. What would be on your list? Like, how do you get started?
So I would say, if there were 3 things that I would say you have to understand about AI. One, you have to understand the economic imperatives of it, right, from the beginning. And at its base layer, if you're going to get started and you're going to do one thing, you're going to use AI to predict something. There's actually a really good book written by a couple of economists. It's called Prediction Machines. And Prediction Machines looks at the typical economic viewpoint of, when something goes down in price and you get more of it, what does that mean? So if prediction goes down in price, instead of having to pay somebody who might be $100,000, $150,000, $200,000 a year to be an expert in this topic and can predict, where things are going. If I can predict that with a model now, and that model runs for, dollars a day, well, what happens to predictions? Well, you can predict stuff that you couldn't predict before because maybe it wasn't economically feasible to predict it. Right. And then what goes up in value? Well, judgment goes up in value because when you're making a lot of predictions, you don't always blindly follow the predictions. Even when humans make them, you might say, okay, well, that's great. And maybe you're right, but there are these other factors to consider. So number one, I think you need to think about that, the economic cost of AI and how it's going to impact your business. Number two, you have to think about data drift. If there's one mistake that I see people making time and time again, it's assuming that they can sort of like get some data and train a model and be done. But when you put these things out in the world is always changing, right? And just to give you a simple example, look at language, right? So if you're going to train a language model, well, language changes and evolves over time, not day to day, but new celebrities become famous. Some of them have, names that we haven't heard before and might change the meaning of words. The usage of words, if you said in 1940, if you said surf the web, that didn't mean anything. And so as language changes and evolves, you get this drift in what the data may mean that you need to factor into your model. It's very similar to if you trained a model to predict the height of humans at birth, and you did that in 1850 and you tried to still use that model today, it wouldn't be valid because we've had changes in health and nutrition and all those things. And so you get this underlying drift in your data set that you always have to account for.
Right.
So you need to build that into your workflows. And then number three, it's very important that when you're launching new AI tools, I would say you need to make sure that you have humans in the loop, right? And what that means is whatever workflow loop that you have that the AI is doing, initially, you either want to have like the AI make a recommendation and the humans say yes or no. And then the humans move to like, okay, we say yes almost all the time. So let the model just do its thing now. But we're still double checking the model. We're still correcting the model. Think about it the way you would think about a new employee, right? They're junior. You're going to initially say, okay, make a recommendation and then you're going to go with a recommendation and then you're going to turn them out on their own, but you're still going to monitor them. And so I think, you still want to have humans in the loop when you use AI tools.
Those are three great things to consider.
They are. So Rob, I'm sure a lot of the folks listening out there are interested in AI, but they might be a little intimidated of it because, let's face it, it is very involved and that can be somewhat scary. And look, I admit I fall into that camp. And I'm interested in leveraging AI here at WIS internally and for our clients, but I'm a bit intimidated to get started. Even though you just laid out those steps. So with that in mind, what would you say to help get me over that hump and take the leap?
Yeah, that's a great question. And I get that a lot. I actually got asked in 2017 to do a presentation from scratch on this topic. And so I spent a lot of time thinking about it. And there's a lot that you could do with AI. And if you read the news and you read the papers and people are doing the research papers, people are doing all these fancy things with it. Most of them aren't going to be relevant for your companies. Many of the tools aren't going to be ready to actually go into a production level system because you may not have the data, you may not have the technical talent to implement them. So I would dial it back in if I was getting started and use a framework that I call the PACK framework. And the PACK framework stands for predict, automate, and classify. These are three things that are beneficial to your business. And they're three things that AI can do pretty well with simple data set. And so what I tell people to do is make a 3x3 box. And on one axis, put predict, automate, and classify as your three labels. And on the other one, put product, customers, and operations, right? And then in each box, come up with ideas that sit at that intersection. So, hey, for predict, what can we predict about our customers that might be valuable, right? For automation, what can we automate about our product or automate about our operations that might be valuable? And then once you fill that out, you might not have something in every box, but once you have those ideas, then you can give those to an AI team and say, these are things that would be valuable to our business. Which ones of these could we reasonably do? What do we have the data to build a model to do? What do we have a way to deploy, that would actually do this work? And so that's how I would go about it. You can actually, if you Google the PAC framework, it's also PAC is also a mathematical term that stands for probably approximately correct. So that'll come up. But if you Google PAC framework and maybe the word predict or something like that, it should come up. I've written a lot about it.
Very cool. Thank you.
I mean, Paul, that's really helpful. I mean,
I just wrote it down. I'm like looking at staring at it right now.
Yeah, I mean, because just having each of those prompts to think about
That's right.
helps you go, okay, yeah, this makes sense for me, or at least I see how I would use it. I think where we get intimidated with all this is because we think we have to create this groundbreaking shit right out of the gate, and I think this just helps you dip your toe into the water.
So true.
So Rob, I don't think we can have this conversation without touching on the fact that look, people are a little concerned about this technology. I mean, the movies, the conspiracy theories on social media, things like that, they've obviously played a role in amplifying our fears and our concerns. I mean, look, recently, a few months back, there was really popular documentary on Netflix, The Social Dilemma, which basically blew me away, personally. I mean, it makes you think like the root AI, thing is going to take the tomatoes and just start fucking throwing them at you.
Throwing them at us.
Yeah. So my question to you is, how concerned do we really need to be about all these things, like our privacy or our jobs becoming obsolete or AI just becoming so smart that it's able to kind of think on its own and just take over?
Well, let me take those in three separate parts, right? Privacy, jobs, and takeover. The privacy one is the one that worries me the most, and it worries me for a couple of reasons. Having spent almost 20 years in tech now, one of the things that we consistently do is we consistently trade privacy for free stuff, and AI really thrives on data. Data is what makes AI models go, and the more data, the more accurate the model. And so there's an inherent tendency in these AI-powered businesses to gather more data, which can always be an intrusion on privacy. And so I think, if you look at other countries, particularly China, they're using a lot of this, right? They're using facial recognition and building a sort of social credit system where they can even tell things like, wow, you've jaywalked a lot. So you're, in terms of getting a loan, your social score is slightly lower. And very strange things like that. And so I think there's going to have to be a lot of government legislation, coming through around, how we deal with this and things, because it's a lot of really complicated stuff. I think in terms of jobs, here I'm not so worried for a couple of reasons. Number one, if you look at the history of technology, so far jobs have tended to be replaced. Even in things computers can do better or machines can do better, it sometimes becomes a status symbol for humans to do them. So you look at something like books, right? Well, when Amazon came out, I mean, you remember back in the early 2000s, people were like, "Oh my gosh, bookstores are going to go away." Yeah. And while it did hurt some of the mega bookstores, it really sort of made independent bookstores, I think, flourish. And it changed people's view of physical books from, from just, things that you just shoved on a shelf somewhere to more status symbols and like coffee table books and like all that. And you've seen similar things with like horses, right? I mean, 200 years ago, we all would have ridden around on horses and everybody had a horse. And with the advent of a car, horses became a status symbol. So if you know somebody now who owns a horse, right? I mean, they cost $25,000 and they cost $1,000 a month to keep, and so it's something that the upper class does. And so I think you'll see stuff like that for quite some time. Now, is there a point 30, 40, 50 years out where machines do everything better than us? Possibly. But when that happens, I think there'll still be some, having personally tailored clothes or having humans do your thing will be a sign of status, and humans are always looking to differentiate amongst each other by status, right? So I don't think that'll go away. And then when I think about an AI takeover, I don't know. I don't think there's any reason to think that we are close to building a conscious machine. I think it feasibly could happen someday, but I think it's 30, 40, 50 years away. And if it happens, I don't have a reason to think that it would want to wipe us out, as opposed to maybe just like ignore us. I think there's a lot we don't understand about human motivation and why we do things. And there's probably some biological programming there that a machine won't have. And so what the machine's motivation to do I think is still a lot up in the air. So I'm not worried too much about it. I like that there are people that are working on AI safety already and saying, well, we should at least engineer these systems in safe ways so that they have shutoffs and controls. And but it's not something I lose sleep over.
The privacy one is obviously a concern for me as well. And I think as you even talked about it, I was like, wow, you don't even know what you don't know, because you don't know how people are going to apply it. And it feels like it's always a game of catch up. Like, oh, they're using the information for this, or they're using it for that, and it might be ways that you just never thought they would use it, or you never considered it, and all of a sudden you have to put a rule or a law or something, a policy in place.
Yeah, and I worry a lot about that specific issue because you get into a lot of ethical questions, right? And so it's interesting. Like I know, a lot of people that work in finance and accounting, you have ethics training and stuff like that, and you study fraud and all that. And in some disciplines of engineering, we have that. Civil engineering, most of those courses require an ethics class because you can't skimp on building a bridge or an elevator or whatever and have it crash and kill people. But most computer scientists don't ever have an ethics course. And so when you get into privacy and you think about things that are coming like the ability to hyper personalize e-commerce, right? And so not just to say, hey, you're this kind of person, but you are exactly who you are and everything I know about you. Well, what happens when you know people's weaknesses and you sell them something that maybe is they're trying to fight off, right? Maybe you show them a casino ad when they're a compulsive gambler.
Yep.
Well, what are the ethics around that? Like, I don't think people should be doing that, but that might be what the machine figures out it should do.
Correct. Got that. Yeah, that's a great point. Yeah. So Rob, obviously, this is one of those episodes where pulling together the perfect questions is kind of tough, because we don't even know what we don't know. So what did we miss? In other words, are there any questions we should have asked you as part of this 101 that we didn't?
Well, the biggest thing that people miss when they start to get involved in AI is how differently these data science and AI teams work than engineering teams work, right? And what I mean by that is, if I'm going to lump AI and machine learning together with the broader class of data science, when you're trying to put that into products, it's just not as well defined as engineering. And so let me give you a couple of examples, right? One is, if I have a website and it gets 100,000 visits a month and I expect to grow to support 1 million visits a month, and I talk to my engineering team about that, they kind of have an idea of the things that need to happen to make it support 1 million visitors a month. And they might be off a little bit, it might take some time to do, but in general, that path is known. If I have a machine learning model that is trying to predict something, and it's 88% accurate at that prediction, and I say, well, that just won't work for my use case. I need it to be 94% accurate. Mm-hmm. Your data science team doesn't necessarily know what it takes to get to 94% accuracy, or if they can even get there. They can try gathering more data. They can try some different data science or different machine learning techniques or architectures. So the question becomes, instead of, they don't even have a gut feel for what it might be. So sometimes it's just like, well, how long do you want us to try this? Do you want us to try it for 2 weeks or 2 months or 2 years? At what point do you give up and say, we just can't achieve what we want to achieve? And so I think a lot of people don't understand that data science teams work very differently. There's still a lot of art, over science. And so trying to get those to map into like product roadmaps and traditional engineering roadmaps can be challenging. And so you have to, you really have to think about that, how to handle that.
Yeah, that's really helpful. I mean, hey, Rob, another thing before we sign off, I mean, I'm sure some of the listeners are going to want to learn more. So I'm wondering if maybe there's some resources that you recommend. Obviously, Inside AI, which is your newsletter. You did mention the book Predictive Machines, I believe you said it was. But are there other resources, maybe it's books, podcasts, articles, things like that you think would be helpful just from a beginner, starting out standpoint?
Sure. So there's a really good book if you're interested in the varieties of AI and what might be coming down the road. There's a really good book called The Master Algorithm. It's written by a professor at Washington named Pedro Domingo, and he lays out the different forms of AI, and it's written for like the intelligent layman. So it's pretty good. And there's a really good book written by an HBS professor named Kareem Lakhani called Competing in the Age of AI. And it's one of the better books that I've seen that lays out how does AI fundamentally impact business strategy, right? So if you're going to take a Michael Porter's 5 Forces value chain view of the world, what does that mean for AI and how does AI impact this? So I really like a lot of that. I don't have any good podcast recommendations, but I will tell you I am going to start a podcast. It'll actually launch in March called Investing in AI, which looks at AI across public and private markets and what some of the market impacts and business impacts of AI are. So stay tuned for that.
Great.
Very cool.
And there are some really good newsletters out there. So, Inside AI, I write the weekend commentary and they have a reporter that does the daily sort of AI news. But there's a couple other good ones. There's a guy named Jack Clark who works for OpenAI, writes a good newsletter. And then Nathan Benash from Air Street Capital in London writes a lot of really good stuff. So those are some of the people I would check out and some of the things I would pay attention to.
Yeah, that's great. We'll include some of those links too in the description for this episode. But Rob, man, thank you so much for coming on and doing this. I mean, this was a great overview.
Yeah, Rob, thank you. And like John said, there's going to be people out there who start to geek out on this, and they're going to want to learn more. And they'll definitely have more questions. So don't be surprised if we ask you to come back on in the future to address those.
Yeah.
Well, thanks for having me, guys. It was a lot of fun, and I'm happy to come back anytime and do any topic more in depth. So.
Well, we appreciate that. And there you have it, everyone. I mean, that an AI 101 from one of the top experts out there. We hope this helped you get maybe just a bit smarter on the topic and maybe even inspired you to start considering some AI strategies, even do that PAC exercise that Rob talked about for your business. But this was really great.
And we'd love to keep this conversation going. If you could use the comment section to do that, that'd be great. So feel free to post your thoughts on everything from companies you think that are using AI effectively to the way that your company perhaps is using AI or your plans to do so, to even information or resources that you think would be helpful to everyone listening. And even if you have some questions that you'd like us to ask Rob offline for you, please feel free to do that. Because the more insight and the inspiration we have about this topic, the better it'll be for all of us. So thanks again, Rob. I know I learned a lot. I'm sure our listeners did too. And thank you all for listening.